This week at NASA.
You can see the parachute coming down and the plume coming up from the soft landing engines.
The Expedition 35 crew safely returned from the International Space Station with a parachute-assisted landing of its Soyuz spacecraft in Kazakhstan on May 14th local time. Commander Chris Hadfield of the Canadian Space Agency, Soyuz Commander Roman Romanenko of the Russian Federal Space Agency, and NASA flight engineer Tom Marshburn capped off 146 days in space full of activity. For Marshburn, some of it just hours before the crew departed. On May 11th, he and fellow NASA astronaut Chris Cassidy completed a 5-hour, 30-minute spacewalk to replace a faulty coolant pump on the station's P6 truss. The quick turnaround spacewalk was orchestrated just 48 hours after a coolant leak developed on P6. And during a NASA TV in-flight event on May 7th, Marshburn discussed the work being done on the International Space Station with members of the Senate Committee on Commerce, Science, and Transportation Subcommittee on Science and Space. Chaired by Florida Senator Bill Nelson, the subcommittee conducts oversight of NASA and several other science and technology-related agencies.
Can you explain how, U.S. private space companies are using the ISS as a technology platform?
If they can do it, that is an incredibly impressive technology demonstration. Going into space is not easy. They're coming up with great efficiencies, great new technologies built on what NASA's already done so that they can get probably cheaper, better, faster, get things up to the space station.
Meanwhile, the next crew headed to the space station, Expedition 3637 Soyuz Commander Fyodor Yurchikhin of the Russian Federal Space Agency, NASA flight engineer Karen Nyberg, and flight engineer Luca Parmitano of the European Space Agency fielded questions from the news media as part of their pre-launch activities at the Gagarin Cosmonaut Training Center in Star City, Russia. The crew is scheduled to travel to the Kazakhstan launch site May 16th to complete training in advance of its launch to the station on May 29th local time. NASA Administrator Charlie Bolden delivered opening remarks at the Humans to Mars Summit at George Washington University. The 3-day event held by Explore Mars and GW's Space Policy Institute provided a forum for NASA and the space community to discuss technical, scientific, and policy-related challenges associated with sending humans to Mars by the 2030s.
There are technological gaps to sending humans to an asteroid and to Mars. And so every single moment of our time and every single dollar of our assets must be dedicated to developing those technologies that allow us to go beyond low Earth orbit.
Also discussed the planned NASA initiative to send humans to an asteroid and the importance of work by astronauts during long-duration missions aboard the International Space Station. While not specifically designed to send humans to Mars, these endeavors will provide invaluable experience useful in planning and completing a successful human journey to the Red Planet.
Also, we need to think about what we carry in terms of medical equipment for the crew, other things along those lines, so we get a chance to experience a different risk environment where we have a protracted return capability back to the Earth. And I think that's what we're going to have to do as we go to Mars.
Skylab, the nation's first space station, launched aboard a Saturn V rocket 40 years ago on May 14, 1973. The 3 crews that completed missions aboard the experimental facility not only set successive new records for long-duration spaceflight, but also completed about 300 experiments covering physical and biomedical science and Earth and space applications. The Skylab program also yielded knowledge that was eventually used in development of the International Space Station, just as the work being performed on the ISS now is helping NASA develop new missions that will extend our reach farther into the solar system.
As humans move outward into deeper space exploration, we'll probably learn things that we weren't expecting to learn, just as we did in Skylab in ISS. And the next things we do will be just as astounding as the step from Skylab to ISS is.
After the final crew left Skylab in February 1974, the empty spacecraft circled the Earth until it deorbited in July 1979. After being incommunicado with the ground during the recent solar conjunction, the Mars Curiosity rover is preparing to get back to wheeling around the Red Planet, and thanks to a software update, the rover now has the ability to navigate more on its own. The new autonomous navigation capability, or AutoNav, enables the rover to evaluate and select safe paths of travel with less input from the rover team on the ground. Curiosity also received a software update to prevent the sensitive telescopic eye of the ChemCam instrument from being burned by the sun. The update is designed to make sure ChemCam's eye is never pointed directly at the sun. And the rover team is also confirming the calibration of Curiosity's navigation cameras before driving to a new location. Plans are in the works for a short drive to a new drill site called Cumberland, about 9 feet west of where Curiosity's drill first touched Martian stone in February. A new Google Earth Engine time-lapse made from Landsat satellite imagery captures the rapid growth from 1984 to 2012 of Las Vegas, Nevada, the fastest-growing city in the U.S. over the past 2 decades. Each frame of the time-lapse is constructed from a year of Landsat data and equates to about a 1.7 terapixel snapshot. Jointly managed by NASA and the U.S. Geological Survey, the Landsat program has acquired images of the Earth's surface since 1972, providing critical scientific information about our changing planet. The time-lapse is located at http://earthengine.google.org/#intro/Las Vegas.
These bugs, flightless fruit flies, may someday help make airplanes more fuel efficient. Their work starts in a wind tunnel at NASA's Langley Research Center, where technicians install the edge of a wing that's covered with a special coating.
The task is to design a surface that prevents insect residues from sticking. Okay? And the reason is that if you have any residue sticking, it trips the airflow over it.
Rough airflow increases airplane fuel usage, as much as 30%, says NASA's Environmentally Responsible Aviation Project.
Between the commercial coatings we've looked at and new coatings and surfaces that we've engineered and modified, we've looked at about 60 different surfaces.
For the bugs, it's up close. They're launched at the coated wing at about 150 miles an hour. The researchers' goal? To narrow the field of coatings to a few that are effective enough to test on an airplane in flight.
2, 1, start.
It was Ready, Set, Soar at the 2012-2013 NASA Student Launch Projects Challenge. More than 600 students launched rockets of their own design, complete with working science or engineering payloads at the event, sponsored by Marshall Space Flight Center. The goal was to see which rocket could come closest to the 1-mile mark and safely return its payload to Earth. Of the 54 teams that participated, 10 received preliminary awards. The grand prize of $5,000 from ATK Aerospace Group will be awarded May 17th after final post-flight analysis and reviews are complete.
3, 2, 1. Roger, have a liftoff and the clock is operating.
On May 15, 1963, Mercury Atlas 9, the final manned space mission of the U.S. Mercury program, launched from Cape Canaveral, Florida.
Hey, Roger, you're looking beautiful.
On board the spacecraft, named Faith 7, was astronaut Gordon Cooper. Despite technical problems near the end of the flight, Cooper and Faith 7 completed 22 orbits of Earth and splashed down safely in the Pacific Ocean. And that's This Week at NASA. For more on these and other stories, or to follow us on Ustream, Flickr, and other social media, log on to www.nasa.gov.